4.3 DeMorgan's laws. DeMorgan's laws. DeMorgan's laws are all about distributing and factoring out a knot. So when I say a knot, I'm speaking of distributing and factoring out a knot where two statements or more are joined with an and or an or. If I distribute this knot, I'm going to distribute it over all three, the P, the and the Q. It's going to become not P, not and is or, and then not Q. Second one will become not P, and when I distribute the not over the or, so not or is and not and is or. There's only two. So if you're not that, you're the other one. And not Q. That's DeMorgan's laws. Now, one thing about this is that you must realize that distributing gets me this, but factoring goes back the other way. If I factor out a not out of the P, it leaves me with just P. If I factor out a not out of the or, it changes to and. And if I factor out a not out of Q, not Q, it should get me back to Q. So you should see it both ways. You should see it distributed coming this way and factoring going back. That's a crucial skill. So let's do some of them, okay? Now, the thing is, we're going to start with the factoring out first, okay? And then after we finish doing these factoring out, we're going to run a little bit of code and see how these things work and make sure that they're correct. All right, factoring out. So if I'm factoring out, I'm taking out a not, and I'm left with an A or B. Okay, so you could see that. Hopefully you can see this both ways. Okay, factor out the not here, the not there, leaves me just at the end of B, and the and gets me an or. Factoring out a not here. Well, A doesn't have a not. So if I factor out a not, I should get a not A. I'm going to distribute the not, and I get a not, should get me back the A. What about the and? Well, the and is going to change to an or, and the not B is going to change to a B. Let's factor out a not again. So here, but this one has a not A, so I'm just going to go with A this time. I'm factoring out an or, so I got to get an and the B doesn't have a not, so I got to get a not B. I'm factoring out a not again. I got an A. So I'm going to get a not A, because when I distribute it back in, I'll get back the A. The or goes to an and we get a B. Now we have another set here to distribute a not. So now I'm going the other way. Distribute this not should get me not A and not B. Distribute a not here. Well, this is a not A, so it gets me A. And then the and goes to an or, and then not B goes to B. Now I'm distributing here again, I'm going to not A, and then I'll get an and not B. Distributing. Distributive property again, we got a not A and a B, because that's a not B, which gets me B back. So that's the idea here with DeMorgan's laws. And it's used to write things that are called equivalent. This is equivalent to this logically, meaning if A is true or false or B is true or false, no matter what combination, these two would yield the same truth table values, the same outcomes. Same is true down here. So if you have code like this, you could rewrite it like that, and vice versa. So this idea of equivalence, let's go test out DeMorgan's laws with code. See what I have here. I have the same two variables we were working with before. And what we have here is B is true, changed to true, and C is changed to false. And I want to know if the factoring out and all that stuff actually works. So let's test them out with some prints, right? See if they work. So the first one here is not on the outside, B and C. So if I distribute the not, it should get not B, or not C. Okay? And I have here a not in front of a B or C, and if I distribute, it should get me a not B and a not C. So no matter what combination I choose, these two should have the same value, and these two should have the same value. Let's check that out. Let's run it. Okay, let's look for the last piece, which is the distributed. Okay. So you see, true and true, false and false. They're going to be identical. Let's make another set of changes here to these bits. Let's make this one false. Okay. So if I run this, true and true, true and true. Okay. I'm not evaluating each one of these. What I'm trying to see is if these two statements yield the same value. And so far they are. What about if I make this one true and that one on top false? Okay. True and true, false and false. What about if I make this true and true? I got false, 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 false. So they're identical. Once I get the Boolean values and I change them in every possible combination, these two yield the same and these two yield the same. Okay? So with the or, we get the same, and with the and, we get the same. Okay? Now, one of the things here about this distributive stuff is that you got to practice. Okay? You can't just write the code here and say I'm done. You got to practice. So what I have down here are some exercises. Okay? And your job is to go ahead and solve them. Go ahead and solve them by writing the equivalent stuff on the right side. So right now I'll do the first one. You see this one? This one here has a not B and not C. Well, that would be the same as if I factor out a not and get a B or C. Okay? So I could see it both ways. Now, as much as we just did this and Boolean logic with these nots, and this DeMorgan's law is very important, sometimes you get lost in what B and C actually is. And I keep coming back to that because that's one of the things that a lot of people have a problem with. Remember that B and C are statements. Okay? So I'm going to go ahead and add some more statements down here. Suppose that we had the statement that X is greater than Y. Okay? Suppose we had that statement. And we wanted to write not X is greater than Y. How would this look? Well, one of the things here is that people would think, oh, I know what it is. I know what it is. It's not X. And then they get to this point and they go not greater than and not Y. That this doesn't make any sense. This is nonsense. Okay? This does not exist. What you gotta remember is that this whole thing is B or C. The whole thing. Okay? So by looking at this, don't confuse this with these. And just to make this a little bit more painfully obvious, I'm going to write something else down here and totally separate these, okay, so that we don't make this mistake. This is not the same as these up here. You're going to go ahead and do these, finish them off, make sure you do. But this is not the same as this. You can't just distribute the not over that. Okay? This whole statement is B. So what we have here is not B. So what we're asking of is how do you write not B in a different mathematical statement? And this is how you write it. X is less than or equal to Y. Let that one sink in. Now you did this in math. When you solve an inequality, when you divide or multiply by a negative, you change the sign. Let that one sink in. Let that one sink in. When you're solving inequalities in Algebra 1, and you divide by a negative number or multiply by a negative number, that sign changes from less than to greater than, or vice versa. So then you should be saying, well, what's this equal to business here? Okay. See, since X is not greater than Y, because that's what the not is saying, Okay? This is saying x is greater than y. Not true. Well, that means x has to be less than, but also equal to y. Don't forget that one, that little one. A lot of people make that mistake because that's a very tricky piece, but it's a logic error if you make it. If I am not greater than y, then I'm either y or less. Let's do another one. What if I had x is greater than y? And then I ask you, how do you write this? The not for it, you should say x. And I hope you could follow this now. I shouldn't say greater than. Let's go with less than because I did that one before. Why would I do it again? I hope you could see that's the solution. Okay? The not just flips the sign. And that's what happened in math as well. So don't confuse this guy with these. See? How do I? So let's say we had x. So here we go. X is greater than y. And w is less than x. See? And now we're doing a not. See? That's what these look like. This whole statement is B, and this whole statement is C. If I ask to write the equivalent for that one now, we want to distribute. So it'll be x is less than or equal to y. Or, pay attention here, not and is or w, okay, some space there, w is greater than or equal to x, and these two right here now are equivalent, okay, because I've completely distributed the not. Okay, so let's not get confused in terms of distributing the not over these signs here, and let's remember this whole thing is actually a statement. Okay, so this is the whole thing here is B, and don't get confused with these two, so make sure we get these clear. So just because of that, I'm going to go ahead now and add an extra 2. So let's say we had not, open parenthesis, and we'll have x is greater than y and w is greater than x, and we want to write the equivalent for that. And another one, let's say we had x is less than or equal to z, or y is greater than m, right? Let's write that. So in this case here, you would distribute the not, and in this case here, we would factor out a not. And because we're doing these as actual statements now, we're going to look at these examples down here and write these examples up here as exercises. So work with these, practice with these. These are DeMorgan's laws. Make sure you practice, make sure you got these down. They're very critical to what we're going to do. Okay, they're very important. Look at them carefully and execute them. They're going to show up on a quiz as well. Okay, that brings us to the end of 4.3.